What's up? Hey guys, we're going to do a test review for probability, which means we're doing a review. There's probably going to be a test, probably on probability, okay? Probably a test. All right, we're going to go over about 7 different types of problems, very brief. I will say we only had 4 assignments this week, so it should be one of our easiest tests of the year. And there's just really only 3 different kinds of angles to show problems. There's numerous different types of events. In probability, you're looking for random events like a spinner, rolling a dice, flipping a coin, picking marbles out of a bag, drawing a card if you have cards, things like that. Okay, that's some of the problems we've had experience with earlier in the year and during this past week. So I will show 3 different types of problems and 7 problems total. Okay. But first, what am I forgetting? Maybe trying to be corny, stupid, goofy with a couple dad jokes? Okay, since you asked. All right, let's take a look here. A couple different types of trees. This is maybe the Northwest. I picture like Oregon or Washington hovering over the trees. Why do trees hate jokes? Because they could get stumped. Oh, stop, Douglas, stop it. Okay. All right, so maybe they could get stumped. Humans could get stumped on a joke too, but anyway, that's pretty cool. I love that, the tall trees being in the forest. Pretty cool. Go on some trails on nature hike. Looks kind of like California, maybe the Northwest yet again. They're not redwoods or anything like California, but pretty cool. So why do you suppose the tree got stumped? It couldn't figure out how to get to the root of the problem. All right. 2 more, bear with me. All right, here we go. I love that green, that bright green color. I picture like North Carolina or something. Maybe if there's a rainy season, you can see maybe get some swampish looking here, flood a little bit. That's the kind of trees that I recall seeing in swamps a lot. Anyway, but the green is so beautiful. Oh, what else do we have? What tree likes to give high fives? Come on, Valley people. A couple of you got it. A couple. The palm tree. All right, last one. This is looking like beautiful. Look at that approach to your property. Okay, and those colors will change throughout the year, but yellow, that is so cool. All right, pretty cool. Maybe South Carolina or something. Georgia. All right. How does a tree use the internet? I know you're playing with everything. You think like branches, leaves. You're thinking of words, you know, that go along with trees and trying to figure out how you can connect it to the internet, right? Sticks. They log on. You didn't see that one coming. All right. Okay, guys, 7 problems. Here we go. Let's take a look. Let's see if I can get along a little quicker nowadays to screen sharing and such. Okay, test review on probability. So there's different events that could happen. They're going to be either simple events, like it's one thing, one draw, one spin, one flip of a coin, etc. Or it could be compound, where it's more than one. It could be 2 events, like we spin the spinner twice, or maybe we flip a coin and draw a marble out of a bag, things like that. Okay, roll a dice twice, things like that. So let's take a look at a couple of examples. Oh, I didn't know. I always tell myself I just do a little bit of talking and I use that time so I can be ready to write. So you don't have to sit there and watch me try to find my writing utensils. Okay, so We could say, we did this a couple of times. Yeah, and I just do it pretty good in person, but that's probably my best one online. So if we roll a dice, this is how they would normally show the problem. P, which stands for probability of a 4 on a 6-sided dice. Well, the 6-sided dice has a 1, a 2, a 3, a 4, a 5, and a 6. There's only 1 4 out of 6 possible outcomes. So the answer is 1/6. Okay? Or you could divide that and get a decimal or convert it to a percentage. We're going to go with the fraction answer. Okay? What's another problem? Let's say you have some cards. We had problems where they would lay out some cards, okay? And let's say we have a 3, a 5, a 7, a 2, and a 3. And they said, what's the probability of a 3? Well, see what I did? Okay. Yeah, look at all of them. They aren't always in numerical order. These are not in numerical order. There's 2 3s. Ching, ching. So it's 2 out of how many total cards I could draw? 5. Palm tree, high five. Okay. So that is my probability, 2 out of 5. Okay. I could convert it to a decimal or a percent. It could be 0.44 or 40%. Okay. All right. So that's pretty straightforward, simple. I could do a flip a coin. What's the odds of tails? I could do a spinner that's got 8 numbers or 8 colors and say, what's the odds of this? Okay. So that's, you get the idea. Let's move on to the next type. Okay. This is going to be experimental probability. Okay. So theoretical is what we pretty much always think of. It's the standard way we think of probability. It's the odds or chances of something happening. Experimental is they're going to say, we did something. This is what the results were. This is what happened. What if we did it 50 more times? Then what? How many times would it happen? Okay. So you're taking your statistics and projecting them into your future hypothesis of what you think is about to happen. Okay. So let's say we did this the other day. We went to a bakery, and a lot of times they have like a little bag of homemade cookies. And your boy here, I was just like, do you have just all chocolate chips? Because it was a mixed bag, and there's always, usually in a mixed bag, some you don't like. Well, it was like 11 cookies. 3 of them were CC chocolate chips. Okay. Daughter got to 1 before I could get them all, but I got 2 of them. So I was a little disappointed, and I'll be honest with you, we threw about 4 or 5 of them away. They're good. They were great baked cookies, but they just there's like 4 that were like cranberry nuts, raisins, and it was just a bunch of stuff, pumpkin seeds. There's a whole bunch of stuff in there, and we ate 1, we split it up, but that's not what, when you want a snack, it's not really. I'm kind of a chocolate guy. All right, so anyway, so they would tell you this: 3 out of 11 are chocolate chips. What if I bought 44 cookies? Okay, what would happen? How many chocolate chips could I expect? Okay, so this is where we would make proportions. Okay, there's a relationship here. Here's the relationship, and the proportion is what happened to the bottom. Can I get from 11 to 44? Well, yeah, times 4. And whatever you do to the bottom, you have to do to the top. Okay, so I could expect to have 12 cookies. Okay, clear. So that's experimental. One more. I have a color wheel, and let's say 1, 2, 3. Now I sliced it like a pizza. There's 8 slices. Take my word for it. 3 out of 8 are the color you see here, green. Okay. So if they said, what if I spun it 8 times? If I spun that wheel 8 times, how many times do I expect to get green? Well, that's what they just told us. It's got 8 possibilities, and 3 of them are green. So that would equal 3. But what if they said, 48 times? Okay, so you're going to do the proportion again. 3 over 8 equals what over 48? Okay, so how does 8 get to 48? Well, and I always tell my kids occasionally if you can't remember something from the multiplication table, go to the next number you do know. Like, I don't know 8 times what equals 48. What do I do know? 8 times 5 is 40. Oh, 40 plus 8 is 48, so it's 6. It's times 6, okay? So just go to the next nearest thing. So anyway, times 6, whatever you do, bottom, gotta do the top, okay? Oh, get out of the way, sir. So that's gonna be 18. I'm gonna get 18 cookies. Or no, I can't get chocolate on the night. I'm gonna get 18 greens off of 48 spins. All right. Okay, that's 4 of the problems. We got 3 left. All right. Okay, get off the test, dude. All right. Let's switch up the colors for fun. Go with what shows up nice. Let's go with I don't think I've ever done pink yet. Okay, pink it is. So now we want to do compound. Those were just asking you one event, one spin, one whatever, flip or whatever. So let's say I had that spinner. That's pretty, okay. And do we want to do colors and numbers? Okay, let's do numbers. 2, 4, 6, 8. So that's going to be 1, 3. Every once in a while, every year, I get somebody say what they don't understand what evens and odds are. So evens, the even numbers are 2, 4, 6, 8, 10, 12, etc. The odds are the other ones. 1, 3, 5, 7, 9er. Okay. So what they said, the probability of an 8 and we'll talk about that in a second. Evens. I want to abbreviate. So I just wrote over my picture. Okay, evens. So whenever we have an and situation, I showed that picture the other day. I don't think I can find it fast enough right now. Okay, fine. Let's do it real quick. We can take 40 seconds. So the other day we did what topic? Is it compound? Yes. Here you go. This is what we did the other day. Let me clear for a second. When you have and, I jokingly said in class one day, add not do, young Skywalker or young Jedi. Multiply you must. I added the multiply you must the other day when I made this. So anytime it's compound, you have multiple events, you're going to multiply the odds times each other. So if they said I wanted a 1 out of 6 on a dice, and I wanted to roll a 1 again, that's 1 over 6 times 1 over 6. That would be 1 times 1 is 1 on the top. You have 1 chance in 6 times 6, 36. That means there's 36 possible combinations and possibilities, but only once could you roll 1 and a 1. So 1 out of 36. So that's why you multiply, because it's crazier odds to get 2 things to happen what you want, unless they ask for something really, and there's a lot of odds in their favor, okay? All right, so now how do I minimize? Hi, Yoda, thanks for coming by. All right, let's see if I can find my way back. Find your way back. Okay. And it was this? No. It was this. There we go. Okay. Thank you for your patience. So I basically had a number queue. All right, where's the draw? Okay. Basically had in picture 1, 2, 3, 4, 5, 6, 7, 8. Okay. I said probability of 8 and evens. Okay, it's sloppy, but there you go. So there's 8 possibilities. To get an 8, that's 1 out of 8. And add not do. Okay, so I'm going to multiply the evens. Well, the evens are 2. Well, let me put one finger for each one. 2, 4. Oh, here you go. You're over here. 6, 8. There's 8 total things. Half of them are even, half of them are odd. So it's 4 out of 8. And then lastly, I always tell my students, whenever you're working with fractions, always try to simplify, okay? So 4 over 8 can be simplified. Divide both the top and the bottom by 4. And that then turns into 1/2. So really have 1 over 8 times 1 over 2. And you would get 1 over 16. So the odds of spinning an 8 and then spinning anything even at all could have been one of 4 other possibilities, okay? 1 out of 16, okay? So if you spin it, you're spinning it twice. 16 times you spin it twice, okay? There you go. All right, and did I lose track of what problem I'm on? That was spinning the wheel. Then you could have where you spin 2 wheels, and let's do, this one has 3, and this side is pink. This one has 1, 2, 3, 4, 5. This one has 5, okay? And we will make the big one pink and this one pink, okay? So if I said, what's the probability of spinning pink and pink? Do that, probability of pink and pink, okay? Well, it's 1 out of 3 on the first thing, and add not do. And sometimes in that word problem, they may not say and pink. Instead of saying pink and pink, they'll say spinning pink on both. And you have to stop and think, is that pink or pink, either or is that pink and pink? That means there's an and there. So add not do, you're going to multiply them, okay? So you got 1/3 chance on the first one and 2 out of 5 on the second one. Now the 2 cannot simplify with the 5, the 2 cannot simplify with the 3. So when multiplying fractions, we just multiply across. 2 times 1 is 2, 3 times 5 is 15. So there's a 2 in 15 chance to get pink on both of those. All right, last one, guys. Oh, let's see, what did I have last? Probability. Oh, it's an easy one. All right. So we haven't done a coin yet. Let's say I have a coin, and I have however many there are. Okay. All right, and I say probability of a 4 and tails. Okay. So I'm going to do 2 things. It's probably got 4 and tails. Well, the 4 is going to be 1 out of 6. There's 6 sides. There's only 1 4. And tails is 1 out of 2. It's a 50-50 chance. Add not do. The plus sign and means add not do. It's going to be multiply instead. 1 times 1 is 1. 2 times 6 is 12. So it's a 1 in 12 chance. So there is 2, guys. I'm going to, let's forget how to do this. I can never get back. There we go. And I gotta go back home. There's no place like home. There's no place like home. There's no place like. And I mean, it's springtime, so I don't know why something got me thinking about the fall colors the other day in one of the videos. I said something, I can't remember what it was. So that made me look up leaves. All right, guys. It is time to leaf. Now that I say that, leave me alone. All right, good luck on the tests. Make sure you did all your 4 homeworks, because this isn't the end of the 3 weeks for a progress report, so I got to enter grades Saturday morning. So, and get your test done before the end of the day. Like I said, seriously, last time I'm going to say this, guys, this is probably I didn't say why the other day. Let me explain to you. This is probably the only chance you're going to have, and probably the only time in my teaching history this could happen, where it's possible that everybody could get 100. The reason the rest of the weeks won't be, because even if we only have 4 assignments each of the next couple weeks, we are going to be learning a few new things to help prepare you for 8th grade, to make 8th grade easier, whether you go into 8th grade gifted and talented, or 8th grade pre-AP, or whether you go into 8th grade accelerated / algebra, etc. Okay, regardless of which place you land or where you go, we want to just help get you a little bit prepared. The district asked us, like, hey, We've already covered everything. We've been reviewing everything. Let's cover a little stuff for next year. Okay, now we're not done. We got a little bit more review to do on some other topics from our year, but there's not much time left, so we will be learning some new stuff too. So that'll be a little different. Blah, 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 blah. Love you, miss you. Stay safe. God bless you and your fam. Ta-ta for now.